So now we're going to take all of the data that we generated for that strong acid, strong base calculation and plot it in what's called a pH curve. What we plot in a pH curve is the pH on the y-axis as it changes over the course of the titration. The x-axis is going to have the volume of sodium hydroxide that we're adding to the solution. So I'm going to show you how I did this. I did this in Excel, and you can either do this in Excel, or you can kind of sketch it freehand. In Excel, I made two columns to kind of plot this data, and in one of the columns, I have the volume of sodium hydroxide that we added. That's the 0.1 molar sodium hydroxide, and I have just the identical volumes from our calculations, and I have all the pHs that we calculated from over the course of that titration. Now, plotting the pH as a function of the volume of 0.1 molar sodium hydroxide that I've added, okay, and just plotting that data, you can see that at the beginning of the titration it's very acidic. I start with a pH of 1 when it's just pure acid, and then the pH starts to slowly go up. Now, as I get close to the equivalence point, remember that pH started to really shoot up. And then at equivalence, the pH is exactly equal to 7, because at equivalence, it's a neutral solution. So this point, midway up the rise in the pH curve, is known as the equivalence point in the titration. And this pH here is equal to 7. And that's going to be true for any strong acid, strong base titration, or strong base, strong acid titration. So after I hit the equivalence point, hydroxide starts controlling the pH of the solution. So the pH really jumps up, and then eventually it levels out. So a typical pH curve for the titration of a strong acid with a strong base is going to look like this. It's going to have this shape. Now, let's say I were doing the opposite. Let's say I'm titrating a strong base with a strong acid. What would the pH curve look like in that scenario? Let's sketch it. Here is a pH curve for the titration of, let's say, sodium hydroxide with hydrochloric acid. Okay, let's just sketch some axes here. I'm plotting pH on the y-axis, and then the volume of the HCl added on the x-axis. So if I'm doing that, think about it. I'm starting with sodium hydroxide. So I'm going to start out with a high pH because sodium hydroxide is very basic. And as I add the hydrochloric acid, it's going to decrease a little bit. Oops, here. It's a little bit too smart for me. Then as I get close to the equivalence point, it's going to plummet, and then it's going to keep decreasing as I add HCl. That's not very beautiful. It really should look like, let's see, it really should look like a reverse of the one that we just did. That's a little bit better. Okay, that's nice. Okay, so we start out with a high pH because we have a base. Then as we get close to the equivalence point, we have this rapid decrease in pH. Midway down this drop is what we call the equivalence point. So if I just take a point midway down that drop, that would be at a pH of 7. That would be where equivalence is in this titration. If I keep going all the way down, then the HCl starts to control the pH of the solution, and I get very acidic pH values. So that's what a typical pH curve would look like for the titration of a strong base with a strong acid.